Welcome, welcome everyone. We are very pleased that you're here for this talk about lawns and how all of us can create lawns that are healthier, more sustainable, and more beautiful. We are honored to welcome one of the nation's leading authorities on organic turf and lawn care, Chip Osborne. Chip, thank you so much for sharing your time and knowledge with us tonight. I'd like to thank our sponsoring organization, Green Acton. For those of you who aren't familiar with Green Acton, it's a local nonprofit that's working diligently to protect and enhance Acton's natural environments for residents of today and many tomorrows to come. Also, thank you to our co-sponsors, Mothers Out Front, Energize Acton, and the Acton Conservation Trust. Thank you to everyone in these four organizations. Quite frankly, you are helping to change our world, and we are grateful. So, just to orient you on the meeting process tonight, we're going to have everybody muted during the meeting while Chip is talking, and we'll hold all questions till the end to give Chip plenty of time to talk. If you have questions anytime during the meeting, please put them in the chat and send them to Christopher Edwards, who is next to me on my screen. I'm not sure where he is on yours. He'll be passing along the questions to Chip during the Q&A. So we've found that this approach sort of helps organize everyone's questions and gets more content to all of us. Also, this webinar is being recorded. You will be able to access it after the event, along with the slides that Chip has created. So please don't despair if you can't write everything down. There's a lot of content here, and we will make it available and accessible to you after the meeting. So now let me introduce Chip tonight. Our speaker tonight is Chip Osborne. Early in his career, he got firsthand experience with the synthetic chemicals that are routinely used in the landscape and horticulture industries. Personal experience led him to believe that there must be a safer way to grow plants. Through his study of conventional and organic soil science and a lot of hands-on experimentation, he became one of the country's leading experts on growing natural, sustainable turf and lawns. He's here to talk to us tonight about how each of us can protect ourselves, our families, our loved ones, create beautiful lawns, and protect Acton's water without synthetic chemicals, and lessening at the same time our use of fossil fuels. So with no further introduction, I'll turn this meeting over to Chip Osborne. Welcome, Chip, and thank you so much for being here.
You're very welcome, and thank you, Martha. It's my pleasure to be with you all this evening and talk a little bit about the subject, which I call a living landscape, a landscape for living. We're going to look at natural or organic management, why we should consider it, and then how to do it. The first part of my presentation will be talking about the issue of pesticides and synthetic fertilizers, where they came from, how they got here, why we have such a great dependence, and some things that you may or may not know about them. And then I'll move into the alternative, which is natural lawn care or organic lawn care, as a counterpoint to the synthetic approach. First thing, we absolutely all need to agree moving forward that we need to learn to embrace diversity. All the expectations that we have for lawns don't have to be that same monoculture of non-native lawn of turf grass. And we need to know that every blade of grass that's grown in North America outside of the prairies and forage grasses are non-native. They're not from here. They came from Western Europe, the British Isles, China, the Orient. So we have all these non-native species that in their own environments were never grown as a monoculture. Yet somehow we've been taught that we have to grow it as a monoculture. The expectations that we have to understand that these expectations were largely created by an industry 75 years ago. We'll talk a little bit about the origin of pesticides and how they marketed early pesticides. But it was the expectation created by the industry that has led us to the monoculture of non-native grasses. And here's a perfect example. This was one of my clients. I work with cities, towns, school districts. I'm a consultant working all over the United States with a variety of projects, probably managing 30, 35 different projects of size right now. And this was one of my residential clients of 80,000 square feet of turf grass. For what? I mean, it's absolutely a waste until I convinced her that this was the biggest expense she had on her property, and it is not sustainable in the least. So this is what we look to move away from. It always sounds funny to people with me as a turf grass specialist, skilled in the whole landscape managing organically, but specializing in turf, that there's too much grass in the world. And there's no question we have been so guilty of putting grass where it doesn't belong. And a lot of that happens in landscape architecture. When there's a question on what should go somewhere, a lot of times turf grass ends up there by default. A good example is a school that was built in my town, and we had a big parking lot, and then we had an athletic field, and there was a sidewalk. But what did they have? 3 feet of grass between an asphalt parking lot and an asphalt sidewalk. It made absolutely no sense. Within a year, it was all weeds. It looked pretty on the rendering and the architectural design, but it made absolutely no sense in reality. So some of this grass should go away, some must stay. Sports, passive use in public parks, golf, a reasonable amount of grass around our homes is all appropriate. We need to change our perception of how that should be managed and what it should look like. Non-chemical management of the entire landscape improves the health of people, pets, pollinators, and plants themselves. So we're looking for a positive human health impact and a positive environmental impact, managing organically in the future. Here's an appropriate, lawn. On the left, an appropriate amount around a building. On the right, those plants you see there, that was part of that large estate where I showed you the monoculture. Those plants were all grass. That was all grass. And my client would never let me get rid of any grass. So I just went in and started tearing it up on my own because I knew it wasn't appropriate. Trying to grow grass in the shade and always fussing with it and dealing with weeds. So we just simply took the grass out and planted what is a much more attractive landscape. So that kind of a change. Believe it or not, American homeowners account for as much or more pesticide use than all of conventional agriculture combined. Turf grass is the largest irrigated crop in the United States. All in the quest of a perfect lawn, all this pesticide, all this synthetic fertilizer use. So my approach is creating an awareness through education, and that's what we're doing tonight. We're educating ourselves on what is a pesticide, and then how do we do alternative management. In the industry, with landscape contractors and for homeowners, a more widespread adoption of these practices is limited only by the lack of education in proper practices and protocols. Most landscape contractors and municipal employees that manage turf grass learned how to manage conventionally. So now they simply need to reorient their education and learn how to manage naturally. So why go organic? Well, when we ask that question, first we need to understand what a pesticide is, what a synthetic fertilizer is. Does the law protect us? Well, I'll walk you through some slides that are basically going to say, no, there is very little protection for us when it comes to pesticides. We'll look at I'm not going to go into detail on health risks, and other than to say that we all know that I cannot make a correlation between chemical A and disease B, but everything from ADD, ADHD, cancers, endocrine disruption, on and on and on. The focus here is about pesticides, not delving into the health or specific environmental issues, but basically stating that we have a problem. Environmental risks, we'll talk about that. What do we do to reduce and eliminate exposures? Exactly what we're doing tonight. We're learning it. When people ask me why go organic, my number one comment is because I want the landscape to get better. Every landscape I've ever worked on and taken chemicals and salt-based fertilizers out of the system and instituted organic practices, everything improves. The health of the plant improves, insect populations, damaging insects go down, weeds can be managed, fungal disease is brought under control, all without product input. We're looking to reduce and eliminate toxic pesticides, protect human health and the environment, being particularly careful about pollinators, reducing and eliminating synthetic fertilizers. We cannot manage an organic lawn by taking away synthetic pesticides and continually inputting salt-based synthetic fertilizers. Salt is not conducive to living organisms. I'll talk a little bit about the biomass, the living organisms, what they do, why they're important. They just don't work with salts. We're looking to reduce inputs over time. In almost every project I do, by the time we get through a transition and we get 3 years down the road, we're using less fertilizer, we're using less water, less labor, less inputs to maintain the same set of expectations. So in Acton and elsewhere, why is this subject important? What is most relevant here? Well, it's protection of your wetlands. Pesticides and synthetic salt-based fertilizers can very easily get into groundwater. They can get into surface water, bodies of water. There's a protection of aquifer and water resources. Gosh, early on in Brunswick, Maine, I was involved in the pesticide discussion, and they ended up, moving forward with some policy. But during one of the early meetings, and this was probably 15, 16, probably almost 20 years ago now, and a soccer coach stood up and said, well, what's the big deal if we damage the aquifer? We'll just go find another one. So, the idea that that's not a true statement, that's not going to happen. Synthetic water-soluble fertilizers are particularly problematic. These are the 4-step fertilizers. They're 100% water-soluble, meaning as soon as they come in contact with moisture, that nitrogen, phosphorus, or potassium is released. And that's a problem because it does not always stay where it's put. Many pesticides do not bind to soil particles. If they bind to soil particles, they can be in the soil for 2 or 3 months or more. If they don't bind to soil particles, they can be gone in 4 or 5 days into groundwater. Synthetic fertilizers. So that is probably one of the bigger issues that can be a contaminant to water. Why do we want to move away from those? Because they consume fossil fuels. 15 or 16% of all the petroleum that's used in the United States today is used in conventional big business agriculture. And the majority of that is used to produce fertilizers. It takes 5 tons of petrochemical equivalent, meaning oil and natural gas, to make 1 ton of fertilizer. So think about that, 5-ton petroleum input to 1 ton fertilizer output. They release greenhouse gases. They disturb soil microbial life. They are basically salts. They upset the balance of the soil and the biological system, and they have a very strong ability to leach. Following a typical 4-step fertilizer application to a lawn, it begins to work in 2 days because it's water soluble. It gets right into the root of the plant. So you're directly feeding the plant. The maximum growth rate of that application is 7 to 10 days after the application. And this is where most leaching occurs. If we have heavy rain events, if you have an irrigation system, and you run it 3 times a week following an application, by the time you're at 7 to 10 days, most of that fertilizer has washed below the root, and it's not doing any good. It's going somewhere else. 4 to 6 weeks after this kind of an application, all the benefit is gone. So it's very short-lived. Little bit about pesticides. Some of you may recognize, some of this. If you have a landscape contractor that is using an herbicide, commonly called a weed killer on your lawn, they might be using that Trimec up there. That's a combination of 3 different chemicals in one bottle because it kills 30 different weeds. All of these are typical. You may have heard about Roundup. Been a lot of press on Roundup in the last 2 or 3 years. When we look at these, we ask ourselves, are they safe when used as directed? And that's maybe what you have heard. Have you been told that they're not a big deal? They don't stay where they're put. They can be moved by wind, water, blowers, transporting grass clippings into municipal compost, and transferred to shoes and clothing and brought right inside, where it can take 5 years to break down in a carpet because you don't have sunlight, you don't have microbial action. You're exposed to pesticides with structural pesticide use. Hotel rooms are regularly impacted with pesticides, schools, around foundations. Pesticides and food, genetically modified organisms. When Monsanto created GMOs, where they put the Roundup gene, the glyphosate, into the gene of the corn plant. So now we have grown corn and soy that are resistant to sprays of Roundup. The plant won't get killed because it has the gene in there. They developed this technology and promised reduced pesticide use, and 15 years in, pesticide use tripled. So Monsanto won on both sides. They own the GMO technology, and they own the chemical that has tripled in use. So you are what you eat. You're eating, if you're not eating organic food, you're regularly ingesting pesticides. And the US EPA, if they find, in one case, they found residues were higher than the appropriate limit. Rather than tell the manufacturer had to bring it down, they raised the limit. So that's how these things happen. Here is oats. This is an oat field. Why is it brown? Because it was sprayed with Roundup prior to harvest. Because Roundup is a desiccant and it dries out. So the whole crop was ready to harvest. They sprayed the whole thing with an airplane. Then they harvest it, and that's where your oatmeal is. The history of pesticides. Rachel Carson, some of you may be aware, she's the woman that brought this issue to light in the late 1950s, early 1960s, and was responsible for having DDT taken off the market and banned for use in the United States in the mid-1960s. So the history of pesticides is simple. It's World War II, chemical warfare research, biocides, Germany and the United States. After the war, all the money that was put into research and development, they needed to recoup that. They became aware that these products worked on weeds, they worked on insects, they worked on fungal diseases. The first insecticides were 2nd and 3rd generation nerve gases, the organophosphates. So we had this now being created, DDT, 1947. Those of us that grew up in the 1950s, almost everything you touched from any food product through dry cleaning and everything else was impacted by DDT. So where we are with this is prior to World War II, white clover was part of every grass seed mix because it fixes nitrogen naturally. The chemical companies came through and said, that clover is not a good guy. That's a bad guy. We have this weed killer here to get rid of the clover. Oh, and we just happen to have a bag of artificial chemical-based nitrogen that we'll put in the system to give you your nitrogen back when you killed the clover. So they were marketed together. At the same time this marketing was all happening, the expectation was being set. Here's Levittown, New York, the first planned community post-World War II, when GIs came back to New York City and they wanted to get out of the city. So Levittown was created. And in the deeds for all of these properties, it was mandated that you had to use pesticides to keep all the weeds out of your lawn so that the community was their picture perfect postage stamp lawn. And a lot of the expectations were created right here. Here is, this is a turf handbook from the early days. And I'm just going to bring your attention over here to the left. And this is the early 1960s. They knew from the beginning that these were poisons. They called them soil poisons. You don't hear that anymore, but in fact, they are still poisons. Federal law defines all of these as pesticides. So herbicides are the weed killers, insecticides for insects, fungicides for fungal pathogens, everything right down to the algicide that gets put in a swimming pool. So all of this is EPA registered as a pesticide. So pesticide is an umbrella term for control products used in any one of those situations. The basic premise, and this is within the EPA and within federal legislation, the basic premise is that pesticides are poisons and they all have some degree of harm or danger associated with them. That danger may be large, the danger may be small. By definition, they're substances that kill, repel, or mitigate a pest. The pest can be the insect, the weed, or the disease. The US EPA regulates and registers pesticides. It's important to note that the EPA registers the active ingredient, and I'll talk to you about what that is. That's all that they register, is the pure active ingredient, without the contaminants and the metabolites. That bottle that I showed you that they said landscapers used with 3 herbicides in one bottle, that bottle has never been tested. The individual 3 active ingredients have been tested, but no one has tested those 3 in combination in that bottle. So they don't register product formulations as you see a brand name in the marketplace. They register the active ingredient. So only the active ingredients are tested. This is the small portion of the product that's designed to kill or mitigate the pest. The testing that's done on pesticide active ingredients is done by the chemical manufacturer or a private laboratory with whom they contract. It is not done by the EPA, and it is not overseen by independent third-party testing. The product that's purchased has not been tested as it's presented in the marketplace, because in the marketplace, there are other things in the bag, box, or bottle other than the active ingredient. The active ingredient can be as little as 1, 2, or 3% of what is in the container. So it can be a very small portion. So think about that. If you buy an insecticide or if you buy grub control that is conventional, that is a pesticide, it's entirely possible that less than 10% of what's in that bag has ever been tested. Everything else untested. That brings us to the inert ingredients. This is the majority of the material that is in a pesticide container. These are the largest percentages, and they are not tested. By law, they do not even need to be disclosed on the container. Many of them are chemicals in their own right and can be more toxic than the active ingredient because they're put in there to enhance the efficacy of the active ingredient. They're proprietary business information and protected by trade secret laws. We don't know what makes up the largest percentage of the product that we purchase. We have no information on potential harm, and many, as I said, can be more toxic than the active ingredient itself. Risk assessment is the model under which pesticides are evaluated. So the EPA looks at the data submitted by the manufacturer and then puts it into the framework of risk assessment. It's risk versus benefit. If the risk outweighs the benefit, the product does not come to market. If the benefit outweighs the risk, the product will come to market. I've been fortunate enough over the last 10 or 12 years to be able to go to the EPA in Washington as part of a group. I sit as a director in the board of directors of Beyond Pesticides, an advocacy group down in Washington. And we go routinely and meet with the EPA. And they actually told us that they believe that they have a responsibility to provide a benefit to the registrant. That's financial, that they have an obligation, that this company spent all this money developing this, that they need to be able to hopefully show them a benefit. So it's not just the benefit of getting rid of the insect, weed, or disease, can be economic. Federal Insecticide, Fungicide, and Rodenticide Act, known as FIFRA, creates all of this risk assessment protocol. The EPA was created under this legislation. The FIFRA was originally written in 1946, revised in 1972, and it has remained unchanged since 1972. 50 years, we are operating under science that was created 50 years ago. And that in itself is problematic because they were only looking at acute exposures. What does it take to kill something? They weren't looking the way science and medicine tells us now that repeated low dose exposures are problematic. So economic benefit, functional benefit, aesthetic benefit is determined in the marketplace. The EPA doesn't even care if pesticides work. They do not monitor or test for efficacy. They came right out and told us we don't care about that. Efficacy is determined in the marketplace. If people buy it, it must work. If they don't buy it, it probably doesn't work. But they don't care about that in the registration process. The risk is the exposure to the human population or the environment. They're looked at for oral, dermal, and inhalation toxicity. This is the basis that looks at the negative effects that higher doses of these materials have on laboratory animals. So they increase the dose until the animal cannot reproduce future generations or till the animal dies. They're looking for acute toxicity. Once they get that, an LD50 is assigned. That's the lethal dose. The value is then extrapolated to the human population using a 150-pound male as the benchmark. No consideration for woman, infant, toddler, child, pregnant woman, first trimester, second trimester, third trimester. Exposures are different in all three, different parts of the fetus. So all of this is to come up with the dose that kills the animal and then extrapolating that. There's something called a half-life. How long it takes for 1/2 of the pesticide active ingredient to be broken down. Only the active ingredient now. How long does it take for half of it to break down? So here we have a sign. Everybody's seen these little yellow signs. Keep off for 48 hours. What if the half-life is between 10 and 70 days for 1/2? And lawn care chemicals, those aren't arbitrary numbers. The more typical lawn care chemicals used in Massachusetts have half-lives between 10 and 70 days for half of it to be broken down. So that sign means absolutely nothing. You have lawn care companies all the time tell you, don't worry about it. As soon as it's dry to the touch, it's not dangerous anymore. Has nothing to do with it. Wet or dry has nothing to do with it. So the quick answer to this sign is that it really doesn't do any good. You may recognize the Wang Ambulatory Care Center. I was taking a close family member to Mass General a number of years ago for chemotherapy and had to walk by that sign to go inside to receive chemotherapy. And do you know that Bayer Crop Sciences that bought Monsanto, which is one of the biggest pesticide manufacturers in the world, also makes chemotherapy drugs? So one side of the company is making materials that can cause cancer, and another side of the company is making materials to treat cancer. So follow the money. Because the product carries an EPA registration number, there's no assumption of safety across the board within the human population. All of these are routine, everyday practices. No framework within risk assessment that looks at repeated low dose exposures, particularly to children. Current science and medical research strongly indicates that many of the products that the EPA regards as lower risk at high doses have been found to be high risk at low doses. Cumulative buildup in children, soccer fields, backyards, baseball fields, day after day, spring season, fall season. So children and sensitive members of the population are not considered when it comes to risk assessment. So that's the bad news, and that's the reality of the materials that we're dealing with. Now we're going to move into what is the alternative? What is it really all about? You may have heard words natural, organic, sustainable. I don't use sustainable all that often because all the chemical companies are sustainable and they all claim to be sustainable corporations changing the way we live for the better. Regenerative is the new buzzword. Organic, if you're truly doing organic, you are in fact regenerative. Regenerative simply means we want to focus on building healthy soil and leave the soil better than we found it. We have created what we call a systems approach to natural turf management. It is the opposite of a product approach. Conventional management, the 4-step program, all of those types of products, most landscapers programs are product-based, product and calendar. Our approach is a systems-based approach that involves 3 concepts: a strong focus on the soil organisms, the biological life in the soil. That's not number 1 by accident. It's number 1 because it's critically important and is the foundation upon which everything else is built. Horticultural practices, the way we mow, the way we water. I guarantee that 75 to 90% of the people that have in-ground irrigation systems are watering incorrectly. That leads to pesticide use. So the good cultural practices, that I'll go through all of them one at a time. And then the use of organic compatible products. There is a nonprofit called OMRI, Organic Materials Review Institute, which was created as part of the National Organic Program to evaluate and certify product for organic agriculture. So when you are looking to buy materials to use around your own homes, if you have any question on whether or not it is truly organic, if you see the label on there that says OMRI, you know that it's the real deal. Organic by neglect is sometimes the general public's perception. I don't do anything, therefore I'm organic. To those of us that manage at this level, it's a well thought out, proactive approach to management. So organic is not reactionary, it is proactive. We're trying to get ahead of things. We're putting a series of preventative steps in place so that problems don't get terribly out of control. The first thing we do is do a site analysis. We look at the site, we understand the site. I encourage homeowners to keep a little journal, note what's going on in different months of the year. Understand how it works. Look at sun and shade. If you have a shady area, you may want grass there in the worst way, but it's not going to be happy. Even when you go and buy shady grass seed, you have to remember that turf grass is a full sun crop. It's just that fescue grasses have the ability to go in a wider range of environmental conditions, so they will tolerate some shade. But at some point, there is going to be a depth of shade that is going to prohibit grasses from growing at all. So we need to understand that. When we look at the site, we're looking at the strengths, weaknesses, and limitations of the site, and we have to be realistic. And we all want certain things in our own home landscapes, but they're not always possible. Just as you've heard that we should be choosing plant material now as native, to Massachusetts or the Northeast, and that it really isn't appropriate in this day and age to be bringing something that was grown in California, even though it may pass for the hardiness zone, for our region of the country. But we want plants that are adapted here because they don't respond they don't have the negative insect populations, the fungal diseases. They're able to stand up to the environmental conditions. So when we have non-natives, we typically have a struggle because the plants are weaker and not adapted to our region. Soil testing after the site analysis, the most important first step. I don't engage for any client, large or small, unless there is a commitment to soil test. So as a homeowner, now is the perfect time if you choose to test your soil and you take a sample, you're going to go around to 7 to 10 different spots around the yard. What I would say is look for light areas. If you have one area that's retained moisture, there may be some moss there, shady. That soil test is going to be a little different than if it's in the hot sun and out, getting sun from dawn to dusk. So you keep those areas separate. If you have a problem area where something is really struggling, don't mix that in with a good area. You'd keep that separate. University of Massachusetts, just umass.edu, type in soil test in the search engine. It will take you right to the soil testing laboratory. And the test that you would do would be the soil chemistry test, just a basic soil chemistry test. UMass makes you check a box for organic matter. That's a critical factor in there because organic matter, the organic fraction of the soil, is the home for the microbiology. So I do 4 tests on every project. I do soil chemistry, which are our nutrients, nitrogen, phosphorus, potassium, and then the second tier, and then micronutrients, organic matter, the pH, which is the relative acidity or alkalinity. Soil texture tells me the percentages of sand, silt, and clay. If you have, if it's new construction and soil was brought to the site, it's not a native northeastern soil, it's an engineered soil. Soil texture may be something to test for if it's a new lawn and struggling. And then soil biological life is a test where we actually take soil and put it under a microscope. And we identify all the organisms that are in there. And we look at their numbers and how much is actively working. So your test would be, as a homeowner, the soil chemistry test. UMass will turn it around in about 3 weeks and they'll make recommendations. In response to that soil test, the first thing you want to look at is the pH. Cool season grasses like a pH that's close to neutral, 6.5 to 7.0. So they will make a recommendation for lime. And that's the first thing that you should do. If you have an acidic soil, you should use lime to get it into the right range, because you can put all the fertilizer in the world down, but if the pH is not in the more desirable range, the fertilizer can't properly be used by the grass plant. I do make the offer when I talk like this. If you do want to get a soil test and you have, I asked, put on the test, you want UMass to give the recommendations to you for organic product. They now include a sheet in there about organic, only because I've been hounding them for 23 years to produce organic, and they're semi on board, but not really. But if you do a soil test and you have trouble interpreting it, you can get in contact with me. Martha has my email contact, and I'll give you a quick rundown. So now we've got the basics underway, and now we understand that it is a transition process. Now, these 3 pictures are all the same site. It's a site that I inherited on the left, where there's a little bit of grass, There's a lot of crabgrass. There's not much of what you would call a lawn. On the right, it was aerated and top dressed with compost. And 2 years later, 2.5 years later, the finished product is the bottom picture. All organic, no chemicals, no synthetic fertilizers. So when a natural management program is put in place following chemical intensive or nothing, I mean, if it's organic by neglect, we probably don't have the soil operating on, on all cylinders. So there's this window of time that we call the transition period. That's the time frame when we make practice and product or input changes and choices. The length of time is related to what we have to work with. How much, if we have a lot of chemicals being used, we probably have a big void in soil biological life, but we probably don't have any weed. If we don't have a history of chemical use, we're probably looking at weed populations, but we're probably looking at a biologically active soil. So either way, we have to begin to make the transition into natural management. Most important part of transition is a focus on the soil. The last thing we focus on is the grass. Because if we focus on the grass in the beginning and neglect the soil, we're going to fail. If we're willing to focus on the soil, and in the programs I develop, half of my product input goes to support the turf grass. The other half goes to feed the microbes in the soil to make sure they're working properly. 4 different expectations here, and expectations can be low, they can be medium, or they can be high. And we've got a little bit of everything right here. Cultural intensity is the words we use to describe everything that goes into managing a landscape. Water, labor, product input, all the resources that go in to creating and then meeting an expectation. Low expectations are not always bad, and high expectations are not always good. It's the right and appropriate expectation for the site that becomes the guideline. When we have in either a conventional or organic program, low level of expectations can be met with low cultural intensity. That translates to a lower cost per 1,000 square feet. Higher levels of expectations, higher cultural intensity translates to higher cost. And the example I use is if you're in the 4-step program and you put 4 bags down, you will meet an expectation. If you only put down 2 of the 4 bags, you're going to realize a lesser expectation. So we just decide where we want the expectation to be and then manage accordingly. For organic management, a high level of expectation can be defined as 5% minus weed pressure per acre. So we're not going to say that there's going to be an acre or 5,000 or 10,000 square feet of 100% monoculture of grass, but when you look at 5% weed pressure over an acre, it's a weed here, a weed there, a little weed there. And in the average lawn, most of that, I've actually done timing with landscape crews of digging out dandelions, hand pulling crabgrass to get things down to a baseline. And believe it or not, it's very affordable to do that. We're now going to begin to think beyond nitrogen, phosphorus, and potassium. Conventional management has us doing an agronomic soil test for soil chemistry and then putting product input in as a relation to that test. We're going to think beyond that. We're going to start to think that less is more, focusing on the biological life. The concept of nutrient cycling is the microbes. It's one organism consuming another and making nitrogen naturally available. Mineralization, the science, the underground portion of the nitrogen cycle. When we're using regular higher rates of fertilizer inputs, microbes get lazy. They just don't work because they don't need to work because somebody's doing all the work for them. So our goal is now to look at and understand how we can be creative by building soils and soil health for internal nitrogen production. So this is an emerging concept of soil fertility, and in conventional management, they laugh at us and say, well, there's no such thing as soil health, soil quality. Soil is soil. Soil health includes the biological aspect of the soil as being equal to traditional nutrients. So when I mentioned we do an agronomic soil test and then put product in there, that's the conventional approach. We are saying that the organisms in the soil need to be considered on equal footing. It's a challenging evaluation. It includes factors that have both direct and indirect bearing on long-term soil health. It's important to understand that mineral soil cannot be healthy by itself. In order to be healthy, there has to be a community of organisms. In natural settings, nature takes care of creating a healthy soil. No one's fertilizing or intervening in either of these landscapes, and they're all thriving and flourishing. So nature has it down pat. But we have been taught for 75 years that our job is to go to war with nature and intervene because we know how to do it better, faster, cheaper, and meeting a better expectation. In a managed environment such as turf and landscape, normal functions are interrupted. These interactive functions that are happening within the system and in the soil, interrupted and often damaged. Here's two residential properties. And again, the project began by focusing on soil health and putting back together soil that had been damaged. So the one on the left was construction, where they just brought in a very inferior soil, a lot of sand, and put it in there. There wasn't much of anything that could be called a natural soil. Same on the property on the right. It was an engineered soil that was created by a soil manufacturer. And the normal interactive functions have been interrupted. And so now they needed to be restored. Restoring these functions in man-made environments is much more easily imagined than it is implemented. It's not easy when you have a soil that has been damaged to put it back together. But what we've done with organic management is come up with the key points that we can talk to folks about the way to do it. And that's where the transition comes in, that we have to focus on soil, and that's what takes time. Healthy functioning of soil comes about when plants, the soil organisms, and soil inhabiting animals actively participate in sustaining their own environment. And that's what happens. Now we have the understanding on what we may need to do to help them rebuild their own environments. Healthy soil absolutely contributes to success. And if we don't focus on that, we very often do not get success. The microbes themselves, natural nitrogen production, solubilizing of soil mineral nutrient, things like phosphorus. You don't need to go out and buy phosphorus in a lawn fertilizer because grass doesn't use much phosphorus. Grass uses very little. So we have a lot of phosphorus in soils, generally speaking, in New England. So we simply need to get that in a situation where it can work for us. And that happens by improving the community of microbes so that they can help to chelate or solubilize this, and then we use it and don't have to pay for it. Water holding capacity. We absolutely will see water reductions in time. So the biological life is involved in creating and maintaining soil structure, plant growth, plant nutrition, disease resistance, nutrient availability, collectively known as the soil food web. So our focus is identifying it and supporting it. Photosynthesis, something you probably learned in high school biology. Over on the right, you see packages of fertilizer. And what did they say? Rose and flower food, plant food, lawn food. That word food is pure advertising. There is no food in any of those packages for any plant. There's simply nitrogen, phosphorus, and potassium, which are raw materials that they are selling you. So the idea that it's food is not founded in science. Photosynthesis is the process where plant food is made. So the ideal height to cut a lawn is 3 inches. That's because we have some blades, and so the blade is green. That's chlorophyll. When you make a fertilizer application to grass, if it's the spring, you get a lot of growth on the top. If it's the fall, you get a lot of root growth. Ideally, you want good growth left and right all year long, and the grass gets greener. The green is the chlorophyll becoming more intense. Chlorophyll reacts with energy from the sun in the presence of carbon dioxide and moisture. Carbon dioxide enters into the blade of grass on the underside of the blade with openings called stomata, and it chemically reacts with chlorophyll. Sugar, amino acid, and carbohydrate is produced. That is plant food. The plant makes its own food. 80% of the carbohydrates that are produced go down into the root system, and half of that becomes an exudate, meaning it gets pushed out of the root system, and it is now sequestered carbon in the soil. So what once was carbon dioxide in the atmosphere is now soil-borne carbon sequestered through this process. The 20% that stays in the up above portion of the plant drives the growth. So what is contained in fertilizer simply needs to be looked at as raw materials that help the plant make its own food. And just here is a diagram. I put this in here so you can see this athletic field is one that we did in Marblehead in 2001. And it has been 100% organic ever since. And it's a showpiece downtown. You can see there's a little clover in here because this is within the footprint of a public park, and it's been a baseball field since 1915. And there was never a mandate. I'm not the one that's going to say clover is bad, because clover is actually very beneficial in this system here. You only see it for about 10 days of the year, and the rest of the time it's just nestled in the grass. But chlorophyll, the process that makes plant food. So now let's look at fertilizers. Fertilizers can be broken down into these 3 categories on the left: organic, organic-based, and synthetic. So synthetic is laboratory created. That's where it takes 5 tons of petroleum to make 1 ton of fertilizer. Organic-based is usually some organic, but it contains urea, which is synthetic, or biosolids, which is sewage sludge compost. When I talk about compost, it is never appropriate to use biosolid compost because of heavy metals and residual pharmaceuticals. So chemotherapy, growth hormones, birth control, antibiotics, all pass through our waste stream. And when wastewater is processed, the water that goes off does not contain the pharmaceuticals. It binds to the solid cake. So when you are fertilizing in Massachusetts at Deer Island, Bay State, fertilizer is sewage sludge. That has PFAS. You probably have heard of PFAS compounds now, heavily impacted in that material. So organic based, you want to stay away from. What we want is organic, preferably OMRI certified, where everything in that bag is natural minerals, or the nitrogen is from grains, plants, and animal byproducts. So that's what makes up, because organic nitrogen is protein. Conventional fertilizers: urea, synthetic inorganic, water soluble, fast green up, petroleum based. directly feeding the plant. We talked about how quickly it leaves. Peaks and valleys, 6 weeks gone, drops down, another 6 weeks, drops down. Price follows the petroleum market. Natural organic fertilizers are water insoluble nitrogen. That means moisture does not release it. Microbes break it down. So the grass plant cannot use nitrogen in the organic form. Single cell bacteria process it. It feeds the bacteria, feeds the biomass. A higher level organism called a protozoa comes along and eats the bacteria, releases that nitrogen in the ammonium form, and now the grass gets its natural nitrogen. So we are feeding the soil and letting the soil feed the plant. Works slowly, steadily, supports the biomass, and is readily available. So if you're a homeowner and you want to fertilize your lawn and you have the highest of expectations, you would put no more than 3 pounds of nitrogen, 1,000 square feet a year, preferably 2. If you're doing the 4-step program, you're putting down 4. That's because it's in and out, where organic stays around much longer. The ideal times to fertilize are mid to late April, depending on the weather, the middle of June, the middle to the end of August, and late September to early October. No matter how often you fertilize, it should be in these windows. You can fertilize once, you can fertilize twice, you could do 3 times, or you could do 4. Typically, fertilizer bags have you put down 1 pound of actual nitrogen for every 1,000 square feet. With organic, we go lower than that. I'm an advocate for lower dose fertility. So 3/4 pound of nitrogen is perfectly fine. For the average homeowner, I would think that we'd be doing between 2 and 2.5 pounds of nitrogen annually. It never should exceed 3. So this is when, and again, with organic fertilizers, because it is microbial breakdown, we need the soil to be warm enough for the microbes to become active. So we're not fertilizing in the 1st of April to get that quick spring green up. It will green up. Nitrogen has very little to do with it. Temperature is responsible for green up. So the benchmark is soil temperatures of 50 to 55 degrees. And that's when you make your first fertilizer application. So that concept that less is more, and then going with the lower dose applications. Proper mowing, sharp mower blades, absolutely important. If you have a Kentucky bluegrass lawn, it's a very difficult grass to cut. If the blade is on the duller side, it's going to rip and tear it, leave a jagged edge. And that's an ideal site for fungal disease to get in and cause a real problem. So sharp mower blades, you're looking to remove about 1/3 of the blade at a time. So if we talk about 3 inches as being the ideal stress-free height, then we want to let it, cut it at the end of the cut. It's at 3. It grows up to 3 3/4, a little more, and then we cut it back to 3. If that is a lush, healthy look. If you are cutting lawns at 1.5 inches or 2 inches, I can design the best organic program in the world for you, but it won't work at a short blade of grass. We need the higher height of grass to choke out broadleaf weeds. It shades the grass, so crabgrass can't germinate. Crabgrass germinates very nicely at 1.5 inches or 2 inches. It does not germinate that well on a thick lawn. If we're managing at the 3-inch height and building good turf density, we can have between 500 and 600 plants in a square foot. That will keep the weed pressure out. We're always mulching. So you want to leave the clippings on the turf. You can get 1 fertilizer application a year just by leaving clippings on the turf. So if I talk about managing a high-end lawn, then I'm going to say that I want 5 pounds of nitrogen, no more than 3 from the fertilizer bag. and I'm going to get a pound of nitrogen from recycling grass clippings, and I'm going to get a pound of nitrogen from the activity of the biomass. Never mow the grass when the lawn is wet. Proper watering practices. I can tell you, as someone that was in the greenhouse business for almost 4 decades, people kill plants with kindness, and that relates to water for people. That if a little bit of water is good, more water is better. Grass falls victim to overwatering so often. My mantra is only water the grass when it asks for it. If it needs it, you can tell and you water it. But if you have an irrigation system that's put in by an installer, installers of irrigation systems really don't know how to water lawns, and they set it to come on every other day for 15 minutes a zone, or 3 times a week for 15 minutes a zone, and walk away. The worst way to water. Deep, thorough, and infrequent is better than shallow. If you're watering with an irrigation system 15 minutes a zone, you're probably only getting out less than 1/4 of an inch of water. So 1 inch of water a week should suffice in May, June, and September. 2 inches maximum in July and August if we have a really hot, dry spell. And then look at what 1 inch of water will do. It'll penetrate sand, sandy loam, which is a soil class, or clay loam to those depths. So what we know we want to do is to put 1/2 inch of water down at each irrigation. So if we irrigate twice a week, there's my 1 inch of water, 1/2 inch at each time. How do you tell that? Get a tuna fish can, put it out in the middle of your lawn zone, run the irrigation system for 15 minutes, and you'll see you collect almost no water. So in reality, you're probably going to run the system for 40 minutes a zone to get that 1/2 inch of water, but you're only going to do it twice a week. And it's going to penetrate, because if you water shallow, roots stay shallow. Then when it comes the heart of the summer, the grass is in trouble. Deep, thorough watering drives the root system down. Compaction is the biggest enemy of turf grass, hands down. With heavy use, traffic, athletic play, pockets of air are eliminated. So we operate on the basic principle in soil structure that all soil particles, from the sand, silt, and clays, and the organic matter fraction, should be surrounded on all sides by pockets of air. This is called pore space, and that contains oxygen. Oxygen is critical for the root of the grass plant, and oxygen is critical to support the microbial population. So aeration is the process that loosens the soil for root development, but most importantly, allows carbon dioxide to escape from the soil and oxygen to move in. Because microbes and turf roots are just like we are. They take in oxygen and give off carbon dioxide. That top left picture there, that's just compaction. The grass that's there is healthy enough, but there's not enough of it. Because when soils get compacted, it's not only losing oxygen, but alcohol is being produced. And it's 1 part per million alcohol can solubilize a plant cell wall. And under there, we probably have 15 ppm alcohol. So we're literally dissolving the root of the turf grass. So in an organic lawn care program, as a homeowner, landscape contractor will do this. You can rent this at Home Depot or Lowe's, and aerating once or twice in the first year, critically important. Overseeding. Infusion of new seed, we simply injecting youth into an aging process. A lawn is a perennial because it comes back every year. But what most people don't realize, so we have to always depend upon regenerating the system. So if we want to get it start this spring, you should go out and find some perennial ryegrass and overseed the lawn, or fill bare spots with perennial ryegrass before weeds get to become an issue, and a comprehensive overseeding in September. Top dressing with 1/4 inch of compost, raking it into the lawn. absolutely one of the best things that you can do. And this is, you'll see, I'm not going to go through this now, but you'll get my PowerPoint. This is what a good compost should contain. Here's our grasses. There's the soil temperatures. There's what happens in the spring. Down in the bottom right are the grasses themselves. And so we have those to choose from depending upon, what our goals are. Does clover have a place in a lawn? It does. I'm doing a project in Manhattan, and we're sowing clover into a residential complex in downtown Manhattan because it is the sustainable way to do things. So, it's not necessarily being the bad guy. I call weeds misplaced plants. These are all some of the weeds that, may find in a lawn, and different strategies. Turf density and loose soil is generally the way to attack these in an organic program, combined with overseeding. And there's one of my projects, and we had a dandelion breakthrough, otherwise pristine turf. No chemicals, no sprays, dug it out, and it was gone for good. So this is high-end organic management with a breakthrough of one dandelion that blew in from a neighbor's yard. Grubs. There is now organic product to work with grubs. It is out there. I'm happy to answer any questions on what that might be, but we look at the larval stages of the growth here, and we know when to treat. It's usually in August in your region of Massachusetts. That brings us to my last slide. How do I talk to my landscape company? We first understand that the companies that work in the industry come down into three different groups. We have lawn care companies. They're the ones that do product applications. Then you have the lawn maintenance companies. They're the ones whose primary focus is to cut grass and do general work, including mulching and cleanups. Some of them do product applications, but for the most part, they strictly are on the maintenance side of it. Then you have the landscape design and install companies, and some maintain after the fact. So when you interview a landscape company, you ask for an organic program. Ask for a specimen label of everything that they're considering putting in there. They have to provide that to you by law for fertilizer and any pesticides that are included. And if anything specimen label comes back as synthetic, then it's not an organic program. And I urge you to be careful. You can go on a website, organiclandcare.org, Connecticut NOFA Organic Land Care Program, where it's a training program for organic landscape contractors. But there's a lot of greenwashing out there, a lot of money to be made. It's a very profitable segment of the industry, fastest growing segment of the lawn care industry. But you're going to ask them for a program, for their proposal, and then the labels to substantiate what it is that they're actually doing. And, the way I look at all this, my focus is to consider what is happening and make improvements over time, so that what we have seen in 75 years of the synthetic world and all the products that we have, if we don't make some changes soon, in another 20 to 40 years, we're going to have significant issues. So happy to take questions. Chris, I'll turn it over to you.
Yeah, no, this is what a terrific presentation. Really excellent. So one question I have, you've been doing this for so long, and you've distilled this into a science. How difficult is it for people who don't have lawn care experts, if they don't hire lawn care experts, how difficult is it for them to do it themselves?
It's really not that difficult. We've simplified it a lot over the years to what what will work in most situations. I still strongly recommend a soil test. Yep. Because putting lime down if you need it is absolutely the first step. Because if you have an acidic soil, which we do in Massachusetts, but grass just doesn't want to be in an acidic soil. A tree does, or a blue hydrangea does, but grass doesn't. So a soil test, and it's only, I think, $25 at UMass. And then we know that I gave you some fertilizer recommendations. Then that organic fertilizer is both stimulating the biological life. At the same time, the biological life is making the nitrogen available to the grass plant. So we're building the soil biology from the beginning. Another product that I recommend that could be included is something called a humate or humic acid, because that is carbon, and carbon is food for the microbes. So as long as we address the microbes with organic fertilizer and hopefully a carbon source, grass seed and aeration, not that complicated. And then it just is some patience. People used to say that it's going to get worse before it gets better, but when an organic lawn gets better, it's going to be amazing. We've got it down pretty much pat now that you shouldn't fall backwards. You should be able to progressively move in the right direction.
How often do you need to do a soil test when the lawn is in transition?
If everything is generally in balance, once every 3 years. If you have a pH that is way off, like down in the low 5s, you may want to lime the first year, and in the beginning of the second year, repeat it, just because it's that important. Very inexpensive. Lime is the cheapest thing that you can do. But if you had a pH below 5.4, say, and you're trying to get to 6.7, a second test at the beginning of the second year is helpful to make sure you get there.
Okay, somebody asked, they've heard of the concept of no-dig gardening to allow soil to retain proper structure. How does aeration fit within this concept?
That's a great question, and it is absolutely in gardening, because what you're doing is, I mean, I grew up back in the old days where you'd had a vegetable garden, you rototilled it every spring, and then you rototilled everything in the fall, and you're constantly breaking up the biomass, all the nice, healthy, reproductive fungi that you'd see in a forest. You're just chopping it all up. So we don't do that. Yeah, that no-till, and you'll still get loose soil. Aeration is a judgment call. If you take a screwdriver, go out to your lawn, if you can relatively easily insert that screwdriver down 5 or 6 inches, you may not need to aerate. If you only get 2 or 3 inches, it's all about the PSI of compaction. Then if you don't aerate, you're not going to grow a lawn. So then aeration becomes critically important, but you're not going to overdo it. You're going to do it infrequently, so that when we talk about aerating a lawn that's heavily compacted for a homeowner, once in the spring, once in the early fall, and that's it. If I'm doing an athletic field in the school district, I'm going to aerate 5 times a year because I have thousands of kids pounding it down. The benefits of aeration only last 3 to 5 weeks. So it's a really short-lived process.
With the are having more and more frequently having water emergencies and the stresses that cause, does that change how you do organic lawn work?
No, we can do it. I mean, we can do on a non-irrigated site, and I've got lots of sites, both public and private, that are not irrigated. And the thing is that you have to have water to grow something. So if you get into a real dry spell, you may, if you put down grass seed and you get germination and it starts to establish itself, and then you don't get any rain for 6 weeks, well, you're going to lose it. So if you have irrigation, it keeps the process moving forward. What we're focusing on in natural management is working with the organic matter fraction. So when you test the soils at UMass, you'll get the organic matter fraction, and it's about 5% on average. And Massachusetts has pretty decent organic matter in soils. So that is the home for the microbes. That's where soil structure is created. If we focus on building the microbial communities with organic fertilizers and maybe the humate, then we are improving organic matter, which acts like a sponge and holds moisture in between irrigations and releases it back to the plant.
Mhm.
So if we embark on an organic program for 2 or 3 years, we're generally looking at a 35% water reduction at the going into the fourth year.
That is really great. I have several questions about specific types of products or things to add. Are there different types of limes to use?
There's 2 different types of lime. There is calcitic limestone and dolomitic limestone. Calcitic limestone is high in calcium and dolomite is high in magnesium. So when a soil is acidic, that means there's a lot of hydrogen being held in the soil. Calcium and magnesium, when they're applied in the form of lime, can be more strongly attracted to those sites that are holding the hydrogen, and either one of those minerals goes on and the hydrogen gets knocked off and the pH goes up. UMass will tell you that. If you need lime, it's based on what the calcium reading is on the soil test or the magnesium. And UMass would say calcitic limestone or dolomitic limestone.
Okay. Okay. There was a question about a recommendation for an organic grub control product.
Yeah, there's a product out there now. There's 2 products. One is cedar oil, so it's just essential oil of cedar wood. A cedar closet and the insecticidal preventative properties that has. So cedar oil just simply goes on as a spray on the lawn, and then you water it in. We do understand that cedar oil can be somewhat antifungal, so it can damage the biomass a little bit, but we would counteract that after the application, maybe a little bit of the organic fertilizer to regenerate, because like I said, the organic fertilizer is food for the biology. So cedar oil is one. There's another product that's out that is a Bacillus thuringiensis, a BT, which is an OMRI certified allowed insecticide, which is a non-living, is a soil bacterium that has come out and been engineered in the lab, is no longer alive, and it has insecticidal properties. And we've used it for years for a variety of insects. 4 or 5 years ago, there was a strain identified that works very well on grubs, and it's marketed as a product called Grub Gone for the grub, or Beetle Gone as a liquid spray for beetles on rose bushes. And I think for the homeowner level, it can be purchased through the Gardens Alive catalog.
Okay. Here's one question. We have a lawn that was chemically maintained by previous owners. Can we just stop the chemicals, throw in clover, and call it a day?
Sure, absolutely, you could. No matter what you do, stopping chemicals, there's no weaning it off of chemicals. That people tell me all the time, well, I'm gonna get rid of half the chemicals, but I'm gonna keep these other half, and I'll just do it slowly. No, it's just boom, stop. But yeah, if you stop the chemicals, I would include grass seed with that, right? Because when something comes out, something has to go in. So if we're taking out the herbicides, pre and post emergent herbicide, pre-emergent goes down before crabgrass germinates so that it doesn't germinate. Post-emergence, selective post-emergence means you spray it on the lawn, it doesn't kill the lawn, but it will kill the weed after it's grown. When that comes out, we need to thicken the turf, as I mentioned. So overseeding with a mixture of Kentucky bluegrass, perennial ryegrass, tall and fine fescue, and Dutch white clover. Absolutely, you could move right on, and that system would begin to transition itself. If it has been getting a lot of synthetic nitrogen, I might tease it out the first year with a couple of applications of organic fertilizer just to build the biology back.
Okay. Another question. Somebody asked, are there any hazards associated with making this transition to organic lawns, and in particular with respect to like children on lawns?
Yeah, no, so when you are using organic product, there generally is no what's called REI, re-entry interval, right? You can be right on there. You can fertilize and go right out there. Any product, just because it's organic does not mean you throw caution to the wind. You have to have respect for all. As I mentioned with the grubs, there are organic insecticides. They don't have the difference between organic. There's organic alternatives to, or natural alternatives to Roundup, but they're generally organic acids. So if you get organic acid in your eyes, you have a problem. So you have to be cautious and respect. So you certainly wouldn't want kids out there when you are making the application. But organic products are not associated with long-term human health impacts, and that's what strongly have. And organic product, I mean, in environmentally sensitive areas, even organic products probably shouldn't be used. And I get very detailed on that when I evaluate a site and say, well, yeah, we have all these organic products, but you're too close to a water source. You're too close. You don't want to do anything. You have to let this go, and you're at the mercy of nature, because the sensitivity of an environmental situation takes precedence over a lawn any day.
For people making the transition with their lawns, are there some grasses that are more appropriate for organic lawn care than others?
You probably want to focus heavily on the fescue grasses. The fescue are the most durable. They take the least amount of nitrogen. They have strong root systems. They're not as fussy. Kentucky bluegrass, which if you have sod lawn, it's probably Kentucky bluegrass, but that is the high maintenance grass, the most water, the most fertilizer, the most attention. So unless you're willing to go to that level, either a mixture of grasses or focusing on the fescue.
Or focusing on is it fescue is very drought tolerant, relatively drought tolerant?
Fescue is the most drought tolerant of the grasses.
Okay. Okay, and I have one more question here. What's your opinion of using compost tea?
Compost tea, I have a slide on compost tea, and when I do a short thing like this, I can't get it all in, and I just took that slide out earlier today to get into my time frame. Compost tea is going to be one of the foundations in the future. That project in Manhattan, it's going to be all compost tea. I mean, this big high-end thing is going to be all managed. We may not even use fertilizer after the first year. It may be just, so compost tea is a liquid extract of a high-grade compost. And so with compost, you get organic matter, you get active biological life, and you get some nutrient, because there's nutrient as part of compost. It's not a fertilizer, but it has benefits in that area. With a compost tea, you get organisms only, biological life only. But making those applications in May and June, and then again in September and October, avoiding the heat of the summer, absolutely fantastic. And you can make some yourself in a 5-gallon pail that you can buy online for $125, $130. And we're encouraging service providers now. And we're going to get the city of New York is going to be, I'm working on properties and parks in 5 boroughs down there. And they're all excited to get their own compost tea machine and start to, brew it and apply it. So yeah, that's going to be one of the cornerstones of the future.
That's great. Let me turn this back over to Martha.
Yeah, thank you. I saw one other question. Any organic and best practices for replacing a large section of your lawn with wildflower meadows?
Yeah.
Any comments there?
That's fantastic. The team that went down to Manhattan included a biological soil scientist, me, and a meadow specialist. So yeah, that is absolutely creating that pollinator habitat, that meadow. And again, it's the same principles that I talked about soils and soil biological life and establishing a meadow. There's protocols for establishing. If you are replacing a lawn, you have to get rid of the lawn. And if you have time, you can solarize it under black plastic, and take care of it that way. But that's going to take several months over the course of the summer to do that. The quicker way to do it is to go in mechanically with a sod cutter and cut the lawn out, but you have to make sure you go deep enough to get any of the reproductive structures of the grass out of there. Otherwise, you'll have grass popping through. And then you have the full palette of what you may want to choose from, to begin to create your wildflower meadow.
Great. Any other questions? Deborah Symes, I see. Is your hand up? Yes.
It is, yeah, thank you. Hi, Chip. I'm wondering, somebody had asked, and I just want to forward this or put it in front of you, whether there's any reason to prefer, if you're going to add clover to your turf, whether there's any reason to go with a Dutch white versus a micro clover.
Yep. We just had that discussion the other day. Micro clover is a hybrid of Dutch white clover. So it's simply a hybrid of that has been bred to have smaller leaves and smaller flowers.
Right.
The general consensus with professionals that have used it is that it tends to revert back anyway, that it stays as micro for a while, but it's not a separate species. It's just a hybrid. And, we've all probably seen roses that are hybridized and you get two different colors on the same plant because it's reverting back to, some, previous genetic. So micro clover is great. But like down in New York, we're going to just use Dutch white and just a little bit. Gosh, it's a tiny, tiny seed. There's several million seeds to a pound of clover, and you're putting it in. Almost the best way to do it is simply, and you can't put it in at more than 5%. If you're putting it into a lawn, if you're making it in a grass seed mix. So this colleague of mine had a great way to it. Just simply took an empty water bottle and punched some holes in the bottom and just went around and shook it out. And you're better off to do that 1 and 2 and 3 times, because if you get it too thick and it becomes a monoculture in areas, that's going to kind of defeat the purpose. So you want a nice spattering throughout, and then it will reproduce.
Okay, any other questions before we?
I had a question about an area of the house lawn that is shaded almost all the time. It just sees a little sun in the middle of summer, and that's it. So the grass hardly grows. What should I put there?
For that, you're going to want one of the turf grass alternatives. There are grasses there are plants that look like grasses. They're called sedges, and then there's carex. Those can tolerate low light that have a grass-like appearance, or there's any one of a number of, shade ground covers. I mean, you can simply go online and there's and just simply Google native ground covers Massachusetts, and then it will give you everything there. But yes, if you're in that kind of shade, no matter what you do with grass, it will never become permanent. You can put the grass seed down in the spring and it will grow, but by the time it comes to September, it's going to be dead and you're going to be putting it down again. So yeah, I would encourage you to find, and then when you simply do that, you find one that's aesthetically pleasing, and you will have several choices and several different looks, depending on what is appropriate for the site and what looks best to you.
There are a couple of questions about whether your principles apply to meadows as well, and if you have recommendations about moving lawns into wildflower meadows.
Yeah, the whole soil biological complex is, we're not putting a lot of nitrogen down in a meadow. But, once you absolutely would do a soil test first. And you're going to, one of the more important things in the soil test outside of the nutrients is the organic matter fraction. And if organic matter is low, 3% organic matter is considered to be the low line for successful horticultural growth. And that's not uncommon in some new construction where they skimp on organic matter. But you may need to incorporate some compost into the area prior to the establishment of the meadow. And that would be done as a result of a soil test. You probably want to get organic matter established somewhere, in the 5% range, 5 to 6% range, because if you can get that established in the beginning, your chances of success are going to increase dramatically. And it's a whole lot less expensive and easier to do it before the fact than after the fact. But all the other thing, irrigation, I mean, the goal is not to water a meadow after you'll cut it. I mean, depending on what you choose for plant material, you're going to cut it a couple times a year to get it established. But you're only going to water it for the first year, maybe first 2 years, till it gets established, and then no more water. And then it goes, it needs to go natural. So water is only for establishment. Not a lot of nitrogen, because the meadow plants don't want nitrogen. The goal in a meadow, and the same goal in a lawn, is I want the microbes to do the work to make the nitrogen for me. And, just as I said, there's a water reduction in time, there's a reduction in fertilizer in a lawn in time, but we absolutely don't want to be putting any supplemental nutrient into a meadow.
Deborah, I see your hand up. Do you have a question?
My
Comment?
last one, two parts. One is, Chip, I really appreciate that you covered all of the nightmares about synthetic pesticides and fertilizers. And I'm guessing people on this call may not have realized how EPA fails us in all the ways in which EPA fails us in this regard. The other thing I want to say is that certainly this is true for Acton, and I suspect it may be true for other communities where there are transfer stations that, create compost in one way or another. Using municipal compost, you just need to be aware that if you go get that stuff and dump it on your lawn or please don't put it on your vegetable garden, but elsewhere, that it's very likely that the compost or the mulch for that matter that you can get from the transfer station has pesticides and synthetic fertilizers in it. So if you really are serious about organic, you really want to be aware of that. Thanks.
Yeah, that's very true. I was involved in municipal government in Marblehead for 20 years and tested all the municipal compost and all of that. And I actually am certified in compost technology and act as a consultant for some large composters and do all of their testing. And composting, as you know, is a heat process. And in municipal transfer situations, you don't know that they've generated the right amount of heat, because it's heat that breaks down any synthetic residues. But when I was testing Marblehead's compost, I was coming up with pretty significant E. coli bacteria readings. So, dead animals or whatever goes in, there's no integrity of what ends up in there. So absolutely never on a vegetable garden. On a lawn, it's generally not of the highest quality, so you're much better off to try to buy it, from a legitimate, reputable commercial producer. And ask them for a test, because all compost is not created equal. I can put 3 piles in front of us and you can't tell whether there's adequate nitrogen, no nitrogen. Organic matter can be 15% or it could be 45% where it's supposed to be. So you should always ask a compost supplier before you buy, can you please show me your most recent testing documents?
Okay, any last question here? I think we're about ready to wrap up. Chip, thank you so much. I cannot thank you enough for this rich and informative and encouraging presentation of yours. I'm so grateful to you for taking your time with us. Thank you so much.
You're very welcome.